Hello my friends, today we're going to talk about emeralds, where they're found, what they are made of, and how they originate. Now, emeralds, a gemstone, variety of mineral beryl, colored green by trace amounts of chromium, vanadium, and beryllium. Has a hardness of 7.5 to 8 on the Mohs scale. Most emeralds are highly included, which means they have a bunch of little specks inside of them of iron ores and things like that. I'm going to explain exactly what you are looking at. I understand this intimately. Now, let's take a look at some specimens that I can talk about that include these particular substances, chromium, vanadium, and beryllium. Alright, so here we have vanadium. It's a transition metal, which all those are. Where is it found? And look at this. It's rarely found free in nature, so they have to extract it from 65 different mineral ores, including petronite, kernanite, and vanadinite. It is also obtained as organic complexes from some crude oils, iron ores, and phosphate rocks. Now, if you're a mud fossil person, you understand what those substances are. The crude oil is literally body fluids. Iron ore is from the blood, ferrous oxides. Phosphate rocks are from tendinous materials and bone matter and all that sort of stuff. Now, let's look at this a little bit deeper. All right, this goes into all the chemistry and how it bonds and all that business. That doesn't concern us today. That right there is what concerns us. This is vanadinite mineral wood print, and this is by photos.com, and they're on wood blocks. He sells these photo prints, but what captured my eye was, I understand this, exactly what's going on here. You see these circular veins in the center? Well, guess what? They're veins or arteries, and this structure around it is exactly how body fluids crystallize, and I can prove what I'm saying. Alright, normally these are found in shales when they find these particular vanadium chunks, and they call it vanadinite. Now, this is the vein, and look at, you see that? That's a wall right there. You see the different little balls? Then you see this, and then you see the center. Same thing here, and then you have this geometric shape around it, and you have a whole bunch of these here. These are all little blood vessels, and they're all in the same spot. And look down here. I'm going to show you something that I can say I'm pretty sure I'm telling you what's true. Now, you can see right here. Somebody would look at that and say, oh, that's a guy with one black eye and one normal eye. Well, let me tell you something. It's a tendon ball. And what you're looking at there is the veins, the vein side, which is the black side. Right, that would be blue in the body. It's black. It turns black. That is the arterial side, and that, my friend, is identical to that. And I will show you very closely. It is absolutely identical to that blood vessel internally. Do you see what you see here? You see the structure around it? Alright, I hope you can see that alright. And then the central core there. Go this way and get a little better light. Alright, that is the artery. And it has the structural wall, and then the internal part was where the blood flowed. That was the vein side, and they plug up and turn black. And the arteries sometimes will leak out like that, or sometimes they will stay red. It's still a little red in the area, but mostly it's completely replaced by silicates. Now, what are silicates? SiO2, SiO3, SiO whatever. They're silicon oxides. And that is exactly what we have here. All of the minerals found in emerald are in the form of silicon dioxides or silicon oxides, and they are all body fluids. And I'm going to show you why I can say that little vein and artery will end up doing these kind of things if it's in solution that is conducive to do that. And I have one that I'll show you did it, but it didn't turn crystal, it just displayed the pattern. You see that? There's your crystalline pattern that forms around, in this case it would have been the artery or the vein, I'm not even certain which it was. But I can tell, this is more important to me than finding these kind of things up there. Those are great, they're fabulous, everybody loves that. But here, I understand what's happening in that fabulous shot. Everybody sends me the money shots. I like where I can see blood. I want to see blood, arteries, veins. I want to see anatomy. I want to see the biology working in the rock. Then I make the statements. Then I make the claims. And I claim that is blood. And that is what happens to blood. It crystallizes in those forms. And that's why they always find these silicates that are in the shape of crystals. That's what blood does. Now I'm saying that blood turns into crystals. It doesn't always turn into crystals like those crystals. It turns into solid minerals. But if it's in an aqueous solution, which means it's continuously being invaded by different types of invasive molecules. There's all these different kind of bonding terms, nucleophilic reactions and ionic bonding and covalent this and that. It's all molecules hook into other molecules, and the molecule that wants the other molecule most is going to win. That's what transitioning is. And I don't think geologists fully understand transitioning to the degree that I do. They will end up, hold on, I'll show you how they're going to end up. This was a heart. And I'll show you, I think I might have a heart over here that's crystal, but I'll show you how they end up. Believe it or not, that was a heart. These were the aorta and the, where the different, see these three different spots here? That's where the blood comes and goes through the heart. And it turns into crystal if it's in the right conditions. You have to understand, there's geomorphism, there's all kinds of different things. There's the chemistry. There's where was it in the body? Was it near the kidney? Was it near the bile ducts? Was it near some other chemistry that caused it to be invaded by these different metals and transition metals primarily, because they're the things that are in your body. They're the things that you find in all of these crystals. The crystals, I'm telling you, crystals are body fluids. I'll show you another one. Hold on. All right, we started on emerald, and we got to the fact that all this bodily fluids turns into literally silicon dioxides eventually, with all kinds of mineral inclusions in them. Red blood. All garnets are made from body fluids. That's what I'm going to say. And here's at the very end, there's your artery there, and that little tiny brown dimple. I don't know if you can see it. Let me see if I can focus in on this little tiny brown dimple. That's the vein clamp, actually. The clear one, I don't know if you'll be able to see that either. But that is the artery, and the artery comes down. Arteries are open, they blow out, and that is literally blood. And you can see there's garnets in there, and all those little crystals are where that blood ran down. And this is the fibrous structure within the fabric of grip skin. That is different than the average skin that's in your body. You know, there's fine skins in your face with all the kaolin clays and so forth. Then you got this strappy stuff is in your grip skin. All right. Now I got something else. Oh yeah, this one here. You see this? That's a heart. I cut that open. I was looking inside of it, and that's where the chambers of the heart are. And there's some black blood in there. This was the side of the heart that pulls in the vein blood, and then the other side is the side that has the real. Whoops. Let me back out here so you can see this. I know you probably didn't see that. This side of the heart is the chamber that had the black blood in it, and the other side of the heart in this area somewhere. It's just hard to say. It's all crunched up. But the other side was the red blood side. I mean, it's obvious. And a heart has those two different signatures. Now, this will eventually bleed out to be just literally almost look like a piece of glass. You're going to find some areas, there'll be inclusions, and that's what they said in these emeralds, there's inclusions. Now, I'm going to show you, they find the emeralds in veins. And they say we find them in the veins, but they don't know what the veins are, and they're calcite veins. And what is calcite? That's it. It's this stuff here. It's the white. It's the clear-looking silicates. All right, here we go. Now, this is the show they had on emeralds, where they finding the best emeralds in the world are in I believe it's called Muzo area down in Colombia, and they're finding them in the veins. Now, listen.
Donde posiblemente encontramos la esmeralda cuando se encuentra en beta. Cuando se encuentra en beta se encuentra en una parte como esta más ancha, blanca, y está incrustada en esmeralda.
That's where the emeralds are encrusted in the white veins.
Dynamite does the digging. The next round of blasting will take them another few yards. They'll blast through rock, trying to keep alongside of the white line. They'll follow it, blast by blast. If the calcite vein begins to widen, that could mean the conditions were right for elements to come together and emerald crystals to form.
Exactly. Those are different minerals that are in different places in the body. I'm not exactly sure where those three different bits of chemistry come together in large quantities of vanadium, beryllium, and chromium. But it appears to be in a region about the size of Las Vegas is what this is. Now, I looked at this from Google Earth, and it is some kind of creature, and it is some kind of reptilian creature that was there. That's all I can tell you. Now, where this was in that creature's body, I'm not sure. But you find different chemistry in different organ areas. The liver, the heart, the kidneys, all have different chemistry. And whatever this is, and the veins that are running through it, sorted out that particular chemistry, because these are white calcite veins. And as I said, that means they were eliminated. They were like that, like this thing. They were like this one that it boiled right out of here, wherever it is. You see, that's the other side of the tendon ball cap. You see? It all boiled out of it. That was blood at one time. It's gone. It's gone. That's all silicates now, 100% silicates. So, that's what happens here, and then those particular types of molecules, atoms, have the propensity to attract to each other in a crystalline form. That's all it is.
It's a bad day if the white took a sudden turn and they blast right through the emeralds.
Fortuito, algo difícil de entrar a determinar cuándo saca esmeraldas.
See, they don't ever know when they're going to get emeralds. They just collect in certain little spots. And it's just coincidence in these evacuated veins. Now, gold is different. Now, here's the deal. Emeralds have a different heavy or specific gravity to them. They don't fall to the very bottom of everything because they are they're in a low weight category. Hold on. All right, they are way down in here, chromium, vanadium, and so forth. When you get up in your gold area, you're way up high in the weights. All right, that's why gold sells to the feet. These things are floating in among the arteries and veins, could be anywhere, because they're basically the same weight as all the other rocks and things that, I think it was like 2.67, yeah, 2.67. They had this particular show is very, very good. They found them at 90 meters deep in Muzo, it's near Bogota, Colombia. They consist of vanadium, beryllium, and chromium of exceptional quality, where there's very few inclusions and they get the nice crystal clear ones, and they are very large. However, you still have to cut a ton of them apart to get to the good ones. Then they had another one in this same thing, this was all about this one. It was 180,000 carats. Hold on, I'm going to show you the things. All right, now listen to this. This was what this story was about on National Geographic. It's about this stone, this cluster of stones they found. And it was so enormous, they couldn't sell it. Here goes.
20 carats and more. When they strike a vein, the emeralds sell quickly and hit markets from LA to Hong Kong several weeks later.
See, all that is shale.
That was the hope for perhaps the world's largest emerald, the Bahia. But it was not to be. The Brazilians hired broker after broker to try to sell it. In 2005, it came to the United States.
It's going to take a little bit more to get this stone sold because it required such a specialized buyer.
How can something be both mesmerizing and unsellable?
At one point, the Bahia Emerald was hidden in abandoned gas stations.
Anyway, you could. It's on the History Channel. I'll see if I can figure out what the name of the show was. Well, I really am not going to be able to be perfectly honest with you. I just clipped this off of there real quick. But it was this particular 180,000 carat emerald, and they're more expensive than diamonds. So, you know, think about what you got there. And they looked like they were pretty good quality, but they couldn't sell it. So anyway, that's how I'm going to leave it. That is the chemistry of crystals. They're organic fluids that percolate through tissues and collect in these empty veins, primarily lungs. They call them vugs. They're holes, they're cavities, and that's where these things form. Lungs are a great spot. Arkansas is loaded with quartz, and I believe that's from lungs. You know, I've looked at a lot of specimens, and I feel very confident in what I'm saying. Anyway, that's the story on crystals for today.